All right, now we're going to do some transformations of our parent functions without a calculator, plotting all of the points that fit on the graph that you're given. So the first thing, you're always going to be given a graph to graph your parent functions, and then you're going to be given enough grids to do one transformation per grid. My advice is to always graph the parent function as specifically as you can, and then if you have any transformations, the first transformation you should graph is the reflection, and then go from there. I think that really works the best. Okay, so this first one, negative ln of x plus 5 plus 2. So we're going to list the transformations for each step as well. So our parent function is ln of x, and we have 3 transformations. The negative out front is a reflection over the x-axis. Plus 5 on the inside is telling us to move our graph left 5. And plus 2 on the outside tells us to move our graph up 2 units. Impossible to do this without graphing your parent function correctly. So our points for ln of x, the big one is 1, 0. And then you have approximately 2.71 and approximately 7.32. So of course, with ln of x and with e to the x, whose numbers are just switched to the inverse, you want to make sure that you just, with those points, 2.71, between 2 and 3, up 1. Between 7 and 8, up 2. That's fine. You're not going to be able to be more specific than that. But make sure that you get those points plotted. The other important thing with ln of x is that if you relied on your calculator to help you, that's okay throughout the unit if you were asking your calculator for a little bit of help. But your calculator lied to you a little bit. The pixels weren't small enough to show you that it goes on forever in the negative direction. So here the range is all reals. You hit every y value, but you definitely do not touch the y-axis. So you have an asymptote there on the y-axis. Okay, so there's your parent function. Let's graph the transformation. So to reflect this over at the x-axis, we're just going to flip our points kind of upside down. Any point on our x-axis doesn't move, so our point at 1, 0 doesn't move, but our point that was between 2 and 3, up 1, is going to flip down. So between 2 and 3, down 1, between 7 and 8, down 2. And now this tail, instead of going down forever, is going to go up. Our asymptote stays that same place as well. Now, our asymptote is going to move here when we move left 5. We want to pick everything up and move it. So the first thing I'm going to do is dot in that asymptote. It was at 0, now it's at negative 5. My first point was at 1, now it's going to be at x equals negative 4. So I'm just picking every point up and moving it 5. And if you need to, kind of dot it in 1, 2, 3, 4, 5. Between 2 and 3, down 1. 1, 2, 3, 4, 5. Between 7 and 8, down 2. 1, 2, 3, 4, 5. Double check that. 1, 2, 3, 4, 5, 6, 7, 8. Yep. So you can't see where I'm pointing there when I'm not drawing, but I'm just counting kind of left to right there. So that's all moved to left 5. And when I move up 2, my asymptote is not going to change. I still have that asymptote at x equals negative 5. Quite good on the one. And now I'm going to move all of those points up 2 units. So instead of at negative 4, 0, I'm going to be at negative 4, 2. Instead of between -3 and -2, down 1. I'm going to go up 2. And I'm going to move up 2. So this point that was between 2 and 3 down 2 is going to be between 2 and 3 and right on the x-axis. Just going to double check my points there. They all look good. Domain here would be x is greater than -5. Range is all reals. So that is number 15.